Today we're going to be doing another free response question that's related to the binomial distribution and also the central limit theorem, specifically involving the normal approximation to the binomial distribution. All right, so a study estimates that 40% of high school juniors have a part-time job. Part A asks, what is the probability that a randomly selected junior has a part-time job? Okay, well, based on the study's estimates, the answer is 40%. And so P, probability of a success, meaning a student who is a junior having a part-time job, is 0.4 or 40%. All right, what about part B? In a random sample of 6 juniors, what is the probability that at least 3 have a part-time job? All right, so this sample is pretty small, and so it's probably not really big enough that we're able to use the approximation, the normal approximation. And I want to explain why that is. The thing is, there's 3 different factors we need to consider in order to do it. First off, were the juniors randomly selected? That condition is met here because they did say a random sample of 6 juniors, so that first one is met. Also, we have to test for independence. And so are the 6 juniors going to be 10% or less of the overall population of all high school juniors? Well, almost certainly, yes. In fact, they'd be even less than that, even if it was just in the context of juniors at a particular school. So, certainly, yes for that one. But the last one says there would have to be at least an expected value of at least 10 successes and 10 failures. And here's the thing, that's not going to be the case here because only 6 juniors are being sampled. And so that condition definitely can't be met whatsoever, given that we would need an expected value of at least 10 for not only just overall, but for each one. For 10 that do and 10 that don't have a part-time job would need to be the expected values, and that just isn't possible here. So therefore, we need to use the uh, probability distribution formula in order to find the probability. Now let's think about what scenarios would have at least 3 part-time students working a part-time job. Well, there's 6 overall being sampled, so we would have to find the probability of 3, that it's exactly 3, plus probability exactly 4, plus probability exactly 5, plus probability of exactly 6. That's one option. We could just find all those and add them all together. The other option is we could notice that what's the opposite of this? We could find the opposite and then subtract the opposite probability from 1, right? Because we know that overall, the sample space, all the sample space probabilities are going to add up to 1. So another way we could do it is we could find the probability of the opposite, which is that not at least 3 students have a part-time job. So therefore, it's either 2 students, 1 student, or no students, and then do 1 minus the sum of those probabilities. And that's what I'm going to do, just because that way I don't have to do as much work. And we always want to take the path of least resistance. So just as a reminder, the binomial probability formula is like this. It's that P of x is equal to k, with k being the number of successes that we're finding the probability of, is equal to n choose k times p to the power k times 1 minus p to the power of n minus k, where k is the target number of successes, right? The number of successes that we're finding the probability of. N is the total number of trials, or in this context, it would be the sample size. So n in this case is the sample size. So how many overall students are we sampling, whether they're a success or a failure? So in other words, sample size or total number of successes plus failures. And then P is the probability of 1 success. So in this specific context, we're going to count a success as one of the people who is a part of this population, right? We're going to count a success as a junior who does have a part-time job, someone who's part of this 40%. Okay, so I'm going to find the probability that nobody in this 6-student group had a part-time job. So for this one, I'm going to be plugging in n is 6, and it's going to be 6 choose 0. And then times p to the power of k, so that's going to be 0.4 to the power of k, which is 0 in this case, times 1 minus p, so 0.6, right? So probability of one randomly selected student, a high school junior student specifically, not having a part-time job, to the power of n minus k. So that's going to be 6 minus 0, so just 6. So 6 choose 0. There's only one way to do that, so that's just 1. Zero point 0.4 to the power of 0 also is 1. So the actual answer to this is just 0.6 to the power of 6. And that's going to be 0.0466656. And there we go. So that's the probability that out of these 6 juniors, nobody had a part-time job. Okay, now what's the probability that exactly one student of these 6 randomly sampled juniors had a part-time job? Well, same thing here. We're going to do p of x is equal to 1. So that's going to be 6 choose 1. We've got to use the order doesn't matter. It doesn't matter if it's the first student, the second student, third student, etc., who is the person who does have that job, right? It doesn't matter who has a success. We're just calculating the probability that exactly one of those students who is sampled has that success. Then we have 0.4 to the power 1 times 0.6 to the power of 6 minus 1, which is 5. So that's going to end up being 6 times 0.4 times 0.6 to the power of 5, which is equal to 0.186624, right? So that is the probability that exactly one of the students sampled in this 6 has a part-time job. The last one I'm going to calculate is the probability that exactly 2 students out of this group of 6 students have a part-time job. So probability x is equal to 2 is equal to 6 choose 2 times 0.4 squared times 0.6 to the power of 4. So that's 6 choose 2, which is 15, times 0.4 squared times 0.6 to the power of 4, and that is 0.31104. So now I'm going to add those up because that is going to give me the probability that 2 or less than 2, right? So 2 or 1 or 0 students had, out of this sample of 6 juniors, had a full-time or a part-time job rather. Okay, so probability that x is less than or equal to 2 would be just the sum of all these. So I'm going to grab my calculator and add these up. And I'm getting 0.54432. So therefore, the probability that x is greater than or equal to 3, right? The probability that it's actually at least 3 students, so it's the opposite of this scenario of being 2 or less, that's going to be equal to 1 minus the probability that there were 2 or less students. And so then we're going to get 1 minus that number. And that is going to be equal to 0.45568. And there we go. Awesome job. So in conclusion, about just over 45%, between 45% and 46% of the time, we're going to end up with a random sample of 6 juniors where 3 or more of them have a part-time job. And we could have gotten the same result from just, instead of doing 0, 1, and 2, we could have also done 3, 4, 5, and 6 and just added those up, and that would have given us the same result as well. Okay, now let's move on to part C. Part C says, in a random sample of 500 juniors, what is the probability that at least 45% have a part-time job? Now, we could attempt to do it this way and, add up all the different ways there are of, what if it's exactly 45%? What if it's 1 more than that, 2 more than that, and so on? We could do that. However, that would take forever, and we certainly wouldn't be expected to do that on the exam. There is a better way of doing it, a much more effective way, and that's to use the normal approximation of the of the binomial distribution. Now, how do we know that we're allowed to do that? I mentioned that for Part B, we weren't allowed to do that because we didn't meet all the requirements. We only met the first two requirements, but not the third one. However, for Part C, we do meet all three requirements. As a reminder, the first requirement is it must be a random sample, which it is in this case. It says random sample right there, so that is correct. It also must be independent, and so therefore we have to assume that the random sample is 10% or less of the population, and this is almost certainly true, right? In the context of all high school juniors who exist in this world or even in the United States, I'm sure that 500 of them is much less than it's 10% of the overall number in the entire country. So that condition would be met as well. And the third condition is that the expected value for the number of successes and number of failures must be greater than or equal to 10. And in this case, if we had 500 juniors, right, we can do this test here actually. We can say that the expected value of successes for a success would be n times p, which in this case is 500 times 0.4. And so, yeah, that's the same as 40 times 5, I believe, which is 200. So, therefore, the expected number of successes, the expected number of students who would, in this 500 student sample, who would have that part time job is 200, and that is far greater than 10. So, we're good there. And then we would do n times q, or n times 1 minus p, which is 500 times 0.6, which is 300, which is also greater than or equal to 10. Or we could even just argue that, oh, well, if the expected number of successes is 200 and the overall number of trials or the sample size is 500, then therefore the number of failures would have to be that other 300, right? Because successes plus failures is going to be that total sample size, is going to add up to 500. And if one's 200, the other's got to be 300. But either way, the point here is that this third condition is met. And so we are able to use the normal approximation for the binomial distribution for this particular example. All right, so how do we do that? Well, first we need to find the mean and the standard deviation. Now, luckily, the mean is just equal to p in this case, which is 0.4, as there's 40% of students 40% of juniors specifically who have a part-time job, so who are part of that. Then we need to find the standard deviation, which can be found by taking the square root of p times 1 minus p over n, where p is the probability of one success and n is the sample size. So that is going to be 0.4 times 0.6 over 500, and all of that square rooted, which is going to be approximately 0.0219. So that's our standard deviation there, approximately. Then the next thing we need to do is we need to find the z-score. So let's remind ourselves what they were actually asking about. They were asking the probability of at least 45 students having a part-time job, right? And so we can assume that this isn't too likely with such a big sample size because the expected number of students that we're going to have is just going to be 200, right? And here they're wanting 45% of the 500, which is more than that, right? We're expecting the answer to be 40%. And so what they're asking here is the probability that it's 45% or more, right? So essentially, to kind of draw a visual of what they're asking, let's say that this is the number here that we would have, right? The mean number that we would have specifically would be exactly 0.4 of the students, right? So that's going to be 200 of them. And they're wanting to know, okay, well, what's the probability that it's here at 0.45 or higher, right? And so already we know that it's got to be less than half. So if we get a number that's greater than half for our probability, then we're in trouble, right? Because we know that this is not as likely as the opposite being true, right? We know it's more likely for less than 45% of the students who are sampled to have a part-time job. Though depending on who we end up sampling, it is possible technically that we could end up with 45% or more of these juniors who we're sampling having that part-time job. Okay, so now we need to find the z-score because in comparison to the standard normal, where is this 0.45? How many standard deviations is it from the mean? And therefore, what would our answer be for the probability? So for that, I'm going to take the z-score, which is going to be 0.45 because that's what we're looking to find. The probability of minus 0.4, as that's the mean, over the standard deviation of 0.0219. Recall that in general, the z-score is equal to the number that we have minus mu over the standard deviation. So we're going to take our number, what we're trying to find out, minus mean, and then divide the whole thing by standard deviation. So if I do that, I get that that is approximately 2.28. So I need to know what's the probability of the z-score uh, being greater than or equal to 2.28. And for this, you can use your calculator as you are permitted one on the AP Statistics exam, or you can also look it up on the z-score table, which is also being provided as well. And so if we do that, we're going to get 0.0113. And that seems quite low. But here's the thing. Here's something we should keep in mind here, because this actually is the correct answer, even though it might seem like, oh, isn't that really low? Keep in mind that our standard deviation was 0.0219. And so keep in mind that means that this 45, the 45%, is more than two standard deviations from the mean, and it's also only one-sided, right? It's students who are, it's the probability of it being this much above that, right? Not above or below, right? So it's also not double-tailed or anything like that. And so we were expecting a pretty low percent here. It's not that likely that if the probability of one success is 40%, that at least 45% will actually be successes when we're taking such a big sample size like 500, especially. It would be a bit more plausible, perhaps, if we had a lower sample size, but keeping in mind how big the sample size is and the way that the approximation to this normal works, that you know what, yeah, this is this is probably about what we were expecting here, given the standard deviation that we had. Now, if we had a bigger standard deviation, then that may have been different in that scenario. But yeah, that is our answer. So basically, the answer here is that there is a 1.13% chance that at least 45% of the 500 students sampled would end up having a part-time job. As always, though, if you have any questions for any of this, feel free to leave those down in the comment section, and I'll see you for the next one.